Welcome to Landis Performance Center. Today we're going to be pulling the engine out of this 88 OBS Chevy pickup truck. We're building a 5.7 LS with twin turbos. That'll be the new power plant for this thing. Here's the block we're using. It's a 5.3. It's been bored out to 5.7 specs, 3.902. And we're going to use CP bullet pistons, Liberty Performance crank and rods, Earl's head bolts, King racing bearings, lifters, Urson cam. We're using 317 heads, which we've corded. They have stainless valves, 1mm oversize, and the appropriate springs, retainers, and keepers for the Urson cam. Because we're using a 317 head with the large combustion chamber, we use a flat top, and once we have it assembled, we'll measure exact, but it should be around 9.4, 9.5 to 1 compression, which will be perfect for the turbochargers. Liberty connecting rods, and there is the stroker crank, so this will be a 383 when we're finished. So follow along and we'll show you the assembly, the blueprinting process. Alright, so we have our rotating assembly laid out on the table, and we're going to start the blueprinting process. First, I'd like to say that all these engine parts came from our friends at Go Racing Parts in Oakland Park, Florida. Great source for engine internal parts. So what we first do is we take a build sheet like this, and we open all the boxes and get all the part numbers and any clearance data that comes with the pistons, the rings, and stuff like that, and we fill this out so that we have a record of all the clearances and the part numbers of all the components we've installed in this engine. May not seem important now, but 3-4 years down the road, when you need to do some maintenance on the engine, you won't be able to find the individual papers. So you do a build sheet like this, and all the information for the entire engine's right there at your fingertips. Store this in a safe place and you're good to go. Now, to do the blueprinting, we're going to use micrometers, inside mics. So we're going to go ahead and start this process. We're going to do it in a speed up mode because it's going to take hours to do, and we want to keep the film it pretty short. But basically, you'll see that we're miking the journals, and we'll put the bearings in the crank, bearings in the block, bearings in the rods, torque to spec, inside mic, check the clearances there. Then the difference between the journal diameter or the piston diameter and the cylinder wall or bearing bore would give you the clearance. So instead of using plastic gauge, which is not very accurate because you're squeezing a piece of wax between two parts, if anything moves or shifts, the wax gets distorted and your size isn't correct. This way we're doing it with a micrometer, and we're doing it by math. Math doesn't lie. So as long as you zero your micrometers right, and then read the numbers, everything will come out correctly. You want to take your time doing this. This is not something to rush, because this is going to show the longevity of the engine. The better the clearances are checked and make sure they are to the proper spec, the more life you'll get out of the engine. We used a micrometer, and we measured the main journals and the rod journals, and we jotted that down on our sheet. Now, what I do is I put it on the back side because this is rough while we're working. Now that I've got it all the basically cheat sheet, then I'll go and put it nicely on the front side when my hands are clean. So the way we do this, and I'm not saying this is 100% the right way, this is just the way I've always done it. I use the micrometer, I'll read the journal, and see if it's within the spec of the manufacturer. Then what I do is I clamp this in the vise with soft jaws so it doesn't put any pressure on here. I use the dial bore gauge and I zero the dial bore gauge to that micrometer reading. Then, as you saw, I put the main bearings in the block, put the caps in, torqued them in place like it's a final assembly, slid the mic into the journals, read X on a couple of them, but read straight up and down, and whatever this reads on this block, it read 2.5 thousandths. That's our bearing clearance now, and that's an accurate by math clearance, not with a plastic gauge or a guess or anything else. It's an actual number. Now, then we take the connecting rods and we go through the same procedure. We put them in the rod vise, take them apart, clean them, we put the bearings in, we put the rod back together. These ARP bolts have a stretch and a torque. So I put the bolts back in with ARP lube, torqued them to spec, but I read the bolt length free and then torqued. And they're supposed to have 5,000 stretch when torqued to 63 PSI, and it's exactly what I had. So now we know what these bolt stretch are. That's a very good thing to know, because now on rebuilds, future rebuilds on the engine, we know that they start out at 5,000 stretch. Once they start going beyond, say, 5.5, 5.5 thousandths, then you know the bolts are going bad and you have to replace them. Otherwise, they'll torque up fine. You'd never know it if you don't check the stretch. So we denote all that in our sheets, and when we have to freshen up this engine down the road, we have all this stuff to refer back to and know where we're at. So now all this stuff will get taken back apart, finish washed, and then more ARP lube applied and torqued back together. Now the main caps, we're going to leave them torqued in, because the next procedure, again, we're going to do it the same exact way. We're going to take a micrometer. On these pistons in the notes, it says 4/10 of an inch down is where you mic the piston insert. So we'll mark the piston at 4/10 down, then we'll mic these pistons. And then again, we'll do the same procedure. We'll put the mic in the soft jaw. We'll make our dial bore gauge, read 0, and then we're going to go through each cylinder, checking an X and Y axis down and top, and then we'll have our piston to wall clearance, again by mathematics, not by a guess. And then we'll file fit the rings, and at that point everything will get blown apart, thoroughly washed, and then the pistons and rods will be assembled, the rings will be put on them, and then we'll put them. All right, so you saw in that section, we measured the pistons. I marked the first one at 4/10 down. We measured that. We measured each piston. We wrote those numbers down. We set up the mic again, zeroed it out, went through the cylinders straight from the top, bottom, and then at the angle of the wrist pin, top, bottom. And we got our piston to wall clearance. Then we file fitted rings. So you saw that we went to the manufacturer's instructions, and in the instructions they said for turbo engine, bore times 0.0055. That gave us 21 thousandths. And they want 4 to 8 thousandths larger gap on the second ring, which is a common building strategy now that I've been using that for the last 10 years. Now, you'll see on here that there's different type of rings. One of the tricks, the second ring was a Napier. So if you look at that, it's got a little point on the end of it. So when I'm file fitting, I put them in upside down so I don't have to worry about chipping those. As far as file fitting, you see I held it up to the light to make sure I had square cuts. Only grind one side, so that way you've got a factory side to line up against to make sure the gap is square. File the where you've ground so that to get rid of the burrs. Always file away from the face, because if you file towards the face, if it's a chrome plated or anything like that, you can flake off the surface that rides on the cylinder wall. So you always go against that. So I cleaned one wrist pin, check to make sure it's slid through the piston and through the rod. At this point, we're going to be ready to clean up all the parts. We're going to clean them all up. We're going to clean our workbench off, get it over as spotless as we can get it, so we have no dirt contamination when we do our assembly. We're going to take the main caps and the rod caps back apart. We're going to 4-0 the bearing surface to get rid of any scratches from the micrometer riding inside of the bearing. Circlips in for the wrist pin. This engine uses a round one. This is kind of like what I first saw 25 years ago in motorcycles. NASCAR started using it, and now it's pretty common. Your wrist pin will have a small taper. If it doesn't have a taper, it's the wrong wrist pin for this clip. But that taper goes and locks that that wire ring into the piston so it can't come out. You have spiral locks that they've been using forever. They're a little bit more of a pain in the butt to put in. Just want to make sure on this style there is a small notch in the piston body. You always want to make sure that the groove is away from that, so that way when you want to take the motor back apart, you can take a pick and pull the clip back out. Otherwise, you can work really hard on it and you'll probably scratch up the bores and mess up that. So that being said, I think that's it for this point. We're going to go ahead and get all these parts washed up, and then we will start doing the assembly. And now we're ready to start the assembly process. So what we're going to do is we're going to put the bearings in, put assembly lube on them, put the crank in, assembly lube the bearings there, tighten the caps to torque specs, and then we'll check the crank end play, and we'll roll the engine over, and we'll start installing the pistons. Now, before we do that, we'll have to put the connecting rods on the pistons and the rings and get all that set up, and then we'll put them one at a time. We're going to take lacquer thinner and a white rag, and we're going to wipe the cylinder walls till they're clean. You'll see even after we've used the degreaser and bristle brushed the cylinders, in the teeth or the grain of the steel, there'll still be some honing material left in the sleeves or in the cylinder. So we'll use a lacquer thinner and a white towel. We'll get that all cleaned out. Once that's all clean, we'll use a 30 weight Joe Gibbs BR brake-in oil, and that'll give the rings a good lubricant to seat the rings back in when the engine's reassembled. All right, so we have all the pistons in, all the rods torqued, and the mains torqued. So during the installation, you saw me rotating the engine, and the reason we do that is we can feel if one ring has got a problem, you get a bind or any other issue, you can feel the smoothness of the engine as it rolls over. In fact, even when just the crank is in, I'll spin it, and that'll make sure that the drag is the same all the way around, all 360 degrees. Kind of shows that the crank is straight and that there's no issues. So as we put each piston in, I'll give it 3 or 4 rotations to get the feel of the drag. And if it feels smooth, then we'll go to the next one, and then it will get a little bit harder as you go, as you keep putting more pistons in. The other thing that we did is there's paint marks. The paint marks tell me that everything has been torqued. The process that we did took all day yesterday, so now it's the next day. So now I know that when I finished, all the rods were torqued, all the mains were torqued, we're all good. Now we'll put the side bolts in. We're going to use a little bit of silicone around the edge, ARP on the threads. We'll torque those in. Next, we'll put the camshaft in. We'll put the timing chain on. We're going to use a deck bridge. And the deck bridge will go over the cylinder wall, and we'll rotate the motor up to TDC, and that will show us how far in or out the piston sits of the deck. We're going to go to a solid piece of metal on the block like this and zero the gauge, and then that will tell us whether the piston's negative or positive. That will also, we use this procedure, we'll go down in the hole 25 thousandths We'll put our dial indicator, or a degree wheel, excuse me, on the front of the motor, and we'll rotate the motor around until we get to 25 thousandths coming up the other way. Then we can see the distance between the two and divide it by 2, and that'll give us true dead center. If you rotate the engine and the piston comes up, you can't find true dead center that way, because as the rod comes up, there's a rollover spot where the piston will not move, but yet the crank will probably turn about 3 or 4 degrees of rotation. So you never get true TDC. So you go down a certain amount and then go all the way around to coming back up to that same spot, and then read your pointer on your degree wheel at both of them, divided by 2, and that gives you true TDC. So then we'll zero the degree wheel, and then we will put our we'll put a dial indicator in this. This is our cam locator. This will go down in the bore of the lifter, and we'll actually ride this ball. Will ride on the camshaft, and then we'll be able to see the lift and duration of the camshaft, which then we'll be able to see the numbers on the degree wheel. We'll use a math formula, and then we'll be able to make sure that the camshaft is degreed to the proper spec on the cam card. You can't rely on timing chains. 0 to 0 doesn't always mean that the cam is going to be where it locates. You have cam manufacturers that can advance or retard from the theoretical TDC of the camshaft, and then you've got timing chains that can be mismarked or ground offset. So you never know if you're truly have the cam set where it was designed to be used unless you put a degree wheel on and degree the cam in. So we'll do that next. All right, so now in time lapse we went ahead and degreed the cam. Now the first chain I put on was one that a friend brought me, and at 0 it was 20 degrees out, and at 8 plus we had only gained 10, so we were still 10 away from where we were supposed to be. This cam is ground for a 108 center line on the intake lobe, and we couldn't even make 100. So we went ahead and put a new Rollmaster timing chain on from Go Racing Parts, and it was really good. So at 0 we did our math, and at 0 we were at 106.20 1/4. So that was really close. So you saw I pulled everything apart, moved the cam sprocket 2 degrees, re-zeroed the wheel, and then redid all the math. So, and how the math works out is 50 thousandths from the base of the circle of the cam. We were at 3 degrees before TDC at 50 thousandths of lift. And at 50 thousandths of lift before it closes, after bottom dead center, we're at 38. So you add 180 degrees, that comes out to 221. You divide it by 2 because it's up and down, so that's 110.5. And then you subtract your start number, which is 3, that gives us 107.5. So we are a half a degree off of what the cam manufacturer recommends. That's close enough, and now we have everything where we need to be. But that's the importance of doing this, because with that other chain on there, we were 20 degrees off. That would totally change the operating RPM of this engine. So this is a very important step. Even if you don't have all the fancy tools, you have to try to figure this out. You can use a dial indicator with a needle going down. You can just use your crank bolt and put the wheel on. The tools I use here just makes it easier for me to do it because we do a lot of them. So anyway, that's done now. We can put the lifters in, we can put the heads on, we can put the timing cover on. We will take these out, put a drop of red Loctite and torque them, and continue on with the assembly. As I was doing the first cylinder head install, I saw that, thought that we should talk about what we're doing. So first of all, this is a tub of oil that I pre-soak all the lifters in. They're hydraulic, so they have to have oil in them to stay pumped up. So I let them sit in there for overnight or so, and that lets all the air get trapped. It's trapped in the lifters, get it all out, and that way the lifters are already primed when they go in the motor. Another thing is I have a tub of ARP lube. Some people use the tubes. I squeeze all the tubes into a holder, and that way I can brush it on, makes it for a little quicker. I wash the deck and the cylinder head off with lacquer thinner with a microfiber rag, because the microfiber really doesn't leave any residuals, and with the lacquer thinner cleaned, that gives the Mahle MLS gasket a good surface to adhere to get sealed up. All right, so now we're gonna go ahead and put the oil pump on. We're using a Mellings 10295. Be careful, there's 3 different Melling pumps. This is one for non-VVT, non-DOD. Those engines require a higher volume oil pump, so you don't want to use that if you're using just a standard engine. They also come with a couple different springs, so you can pick what pressure you want. I'm going to stay with the high pressure. And there's also an O-ring for the dipstick tube, pickup tubes require different O-rings, so you want to verify that. The instructions right here to tell you how to check that out. Now here's the pump. Now one thing I like to do, this is me, because this engine, you can't run a drill and prime the engine like an old school Gen 1 or Gen 2 small block. So what I do is I use a pressurized tank to lubricate the engine. Now, to make sure all the oil goes through the bearings, I pack wheel bearing grease into the pump so that it kind of like blocks it up. But when the motor turns, the grease will disintegrate in the oil, and there's no harm, no foul. The other thing you'll see I'm going to do is I'm going to center the oil pump on the crank. There's a little bit of slop there, not a lot, but there's a little bit, and you can create pressure on the gear and prematurely wear the pump out. So you're going to kind of find the happy spot. I have seen somebody that makes a spacer you stick in there, and that locates it centered. I don't have that. I just go ahead and do it by checking the up and down, side to side, find the happy spot, tighten it down. It's worked well for me. And anyway, so we're going to go ahead and get this portion done and the front timing cover done. Also, on the front and rear timing covers, I use these Mr. Gasket positioners. So you put your timing cover on, you put the positioner on there, that centers the plate to the crankshaft so that the seal has equal tension all the way around. So you'll see while I'm putting that on, you'll see me using that. So here we go. Okay, so now I'm going to do the rear cover of the engine. And one thing, don't ever forget to put this barbell in. And what that does is diverts oil in the block to force it to go through the filter. Without this, the oil filter does nothing. All the contaminants will go right through your engine and right back through your bearings, and the motor will be ruined. So don't forget the barbell. All right, so we're going to put the rear cover on. In that section, we put the valley tray in, or the oil scraper tray. I had to put shims in it because the motor's a stroker, so you got to make sure you have clearance that the connecting rods don't hit the plate. We put the oil pickup tube in. We looked at the instructions from Mellings, and they showed us that we needed to put the green O-ring in. We put the pickup tube in, tightened it all down, torqued everything, measured the depth of the pickup tube, and then measured the depth of the oil pan to make sure that we had over 3/8 of an inch clearance, which we had almost a 1/2 inch. And we put the oil pan on. So that is all done. So the only thing we have left now is to put the trunnion kit in the rocker arms and measure for push rods, and this motor is complete. So now it's time to do the trunnion kit on the stock rocker arms. So these are made out of powdered metal. They're pretty good. We've had them up in the 700-800 horsepower range on natural aspirated. Turbo obviously would be much more. The problem is this tin cup holds the needle bearings in, and it's only pressed in. If that falls out, needle bearings go all throughout your engine. Engine's garbage. And one of the things I like to do is unpackage everything and count everything, make sure we have everything we need. So like these C-clips, you notice there's 2 extra. So if we didn't take this all out of the packaging and count them when we got all done, we'd have extra parts and we'd wonder what the heck happened. So now we know. And this kit from PRW comes with
a kit to take it apart. You set the rocker arm in here. Put that piece there, press it together, and it pushes the stuff out. And you take, once it's out, you put the bearing in, press it in and stuff. So we'll go ahead and do that now and continue on with the build. One thing I forgot to show is on these snap ring clips, there's always a sharp side. The sharp side always goes the way the force would be. So on these it would be towards the outside. The other thing is when you press these in, there's identification markings on the bearing that faces out when you press them in. So we'll go ahead and finish up these last 4 and then we'll be good. So to show how I was doing it, you use a removal tool. It locks in like that. You got a pusher. You can use a press or you can just use a vise like I do. Get that sitting there flat and just tighten it down. And it comes right apart. Now it's ready for assembly. So we'll go ahead and get these last 4 done, and then we'll go ahead and go to the motor and check for push rod length, and we'll finish this thing up. All right, so now we're ready to check for push rod length. So what we'll use is one of these tools here. This is a adjustable push rod tool. Stick it in our caliper, and it measures 7.4002. So 2 thousandths off of perfect 7/400. So we're going to put our rocker stand in with a couple screws just to hold it good. And we want to measure at the base circle of the cam. So just like you're adjusting the valve, when the exhaust valve starts to open, you're going to check the intake side. If you're going to check the exhaust, you have to spin the engine until the push rod on the intake goes up and it's on its way back down. That way you're sure that you're on the lifter is on the base circle of the cam, just like when you're adjusting valves. So we're going to go ahead and do the intake. So we're going to spin the motor over till we see the exhaust push rod start to move up, then we know we got the right length. All right, so we're going to spin the motor over till this push rod starts to come up. All right, starting to come up. So that's, now we know the intake is on the base circle of the cam. These are just extra long ones I had. So now we're going to put the test rod in. We're going to take our rocker arm, stick it on, run it down. We want to find 0 lash. So you can move the rocker arm around. You can see when it starts snugging up. Also, you can turn the push rod. Now the test push rod has a nut on it, so it's easy to turn. Okay, I just stopped. So now we're at 0 lash. And now it's all the way tight on the rocker stand. That was over a turn. So that push rod is the correct length for this camshaft. So anything between 1/2 and 1.5, and you're good to go. If it's too short or too long, then you won't be in that window tightening the rocker arm down, then you know you got a problem. So now we'll get the rocker arms, or the push rod. We're gonna soak these rocker arms, we put them in, but we want to make sure they're full oil inside the bearing. So we're going to put these in a bucket and let them soak overnight, and then put it together, and we'll have our finished engine. And there it is, 383 turbo motor for Chuck's truck. So keep an eye on the channel for future videos when we put the engine in the truck with the 4L80 trans and the Terminator X Max, and it'll be twin turbo. So keep looking for part 2. Don't forget to subscribe, leave a comment, ring the bell for instant notification, and share with your friends. See ya!